Hey, hi everyone. Welcome today to my YouTube channel. And today on a Saturday afternoon, I would be teaching you system design. This is my first system design video. And let's deep dive into the design video. So as you can see, the first video is upon why the system design actually matters. Okay, so why you'd be studying system design, may it be for interviews or maybe for beyond interviews. This video would be useful for people who are preparing for interviews as well as who wants their concepts to be refined, or if anyone is starting out also on system design, this video would be useful for them as well. So let's deep dive in. So this is the episode 1 of the system design series, and basically you'd be focusing on 5 core pillars of system design, that is reliability, availability, scalability, consistency, and cost efficiency. So reliability means systems that never fail, availability always accessible, minimal downtime, and scalability is just growing as far as your demand. Consistency is data staying correct everywhere, and cost efficiency, as it mentions, it's optimizing the infra and usage. If it's not clear, we would go into certain examples, certain real world examples to explain everything in depth. So please stay tuned. So let's move on to the next slide. So system design actually powers the apps that you use daily. So let's say WhatsApp. You have a WhatsApp, and there instantly whatever messages are being sent by someone, it is being received to the intended receiver. So that's reliability. Then you have availability. Okay, let's say there is some Netflix streaming going on 24/7 and with minimal downtime, so the systems are quite available. Then comes scalability. Let's say some IPL matches are going on, so the number of viewers surges. You can expect 10 to 15 times traffic surges, but the system goes on and on. So that's because the system is scalable to handle any type of load. Then comes consistency. So consistency, let's say for Google Doc, let's say someone edits the doc, many people are collaborating and someone edits the doc, so each and everyone would see that edit. Okay, so that's consistency. Next is cost efficiency, where basically you have to optimize your infrastructure spend while scaling. Okay, we will come to certain examples one by one. So first of all, why matters availability? So availability as a concept, what does it mean? It means how often your system is operational and accessible. Okay, it's measured by uptime. Okay, with 99.9% means it's just uh 8.7 hours downtime per year, and 99.99% means 52 minutes downtime just for per year. Okay, so as you can see, Netflix, one of the most popular OTT platforms, which people use on a daily basis, millions, billions of people, they assure 99.99% availability. So how do they do that? It's by following some principles. So redundancy, they have multiple servers on their end and multiple data centers to ensure the continuous operation. Next is the load balancing. They distribute traffic evenly to their servers so that no overload happens. Failover systems, so seamlessly switch. So it might be that some systems fail over, but to seamlessly switch to something else that can actually uh, help being the system available, they have those failover systems as well. And also monitoring and alerts, because without monitoring and alerts, you won't be knowing that what the health of your system is. That's very much needed for rapid response. So example is what I was mentioning. Netflix streams to 190 plus countries. Even 1 hour of downtime is frustrating millions of users. So we'd be using multi-region replication, as I mentioned here, multi-server and multi-data centers, as well as CDNs. CDNs are some we will learn about CDNs later if things are not clear in later videos. But for now, just assume that it is multi-layer, multi-region replication plus CDNs to achieve the uptime of 99.99%. So I hope availability as a concept is clear to you guys. So let's move on to the next slide. So what is reliability? Why does it matter? So WhatsApp has 2 billion plus users who are sending basically or exchanging 100 billion messages every day. So even 5 minutes of downtime, you will see that people are tweeting in Twitter that hey, WhatsApp is down. So basically it's something they want to avoid. They don't they want to give us a reliable system that has the potential to actually send so many messages even during spikes, handle it. So how does it do? So it's by creating a reliable system. So reliability has four important aspects: no message loss. For in the case in use case of WhatsApp, every message must be delivered. Minimal downtime, automatic failover. If one server dies, then the others take up instantaneously. Durable storage, message persist even if device is offline. Okay. So reliable systems are invisible until they break, and when they do, the world notices. So the thing is, WhatsApp, as you can see, sometimes it outages happen, but they are a very high reliable system operating at a very high scale. Okay, so our next slide would be on consistency, one of the fundamental pillars of system design. So, what does consistency mean? It means every user sees the same accurate data everywhere. Okay, how and where is it important? Let's say for banking, a withdrawal must update balances immediately and universally. In e-commerce, let's say someone buys an item and it should become out of stock. That was the last quantity remaining. So then item sold out of stock should appear out of stock for all customers. With messaging also, you should send message and the intended recipient should get it very uh, within some milliseconds, I would say. So it should be consistent. If you have sent it in a group, it must be visible to all other recipients. So consistency is about trust, a system that is fast, but if you show wrong data, you will lose users instantly. Okay, so let's deep dive into the types of consistency that we have. Strong consistency. It means that on each update, everyone needs to see the correct data. This is critical for data integrity. Let's say for banking applications, you withdraw something, the balance should be updated instantly everywhere. It has to be strongly consistent. Some eventual consistency, what is that? Let's say in social media, you someone likes. Okay, the counter may vary from people to people who are maybe viewing the same post. It won't affect that much. Let's say it's 99 now, someone made it +1, then it became 100, but it gradually moved from one user to other. Okay, it's propagation. Updation takes some time to propagate. It should be done as much as low latency as possible, but it's something we can live with. It should not be as strong consistency, but it's eventual consistency. Now, causal consistency. What is that? Let's say operations that are causally dependent, or in simple terms, one depends upon another, are seen by everyone in the same sequential order. What does that mean? For example, in a chat application, let's say someone messages hi followed by hello. So the order should be maintained. It's not hello then hi. Okay. If you change the order, it might mean something else. So we don't want to face those consequences. So the order should be perfect. So that is causal consistency. Next comes session consistency. Okay, so what does that mean? While editing, let's say for a Google Doc, collaboration in Google Doc is very something common. you consistently see your latest changes first, then basically regardless of propagation of delay to others. So let's say you do some edit, you will see that within, I mean, instantaneously, you'd say your latest changes, and then it would be gradually propagated to others. Okay, so that's called the session consistency. Not all system needs strong consistency, and choosing the right type of consistency for your system requires some concepts, thoughts, which we will deep dive into the other system design videos in the latter part of the series. But for now, we are just focusing on it as a concept. Okay, so without further delay, let's move on to the next slide. So this is scalability. Okay, so just before this, just wanted to point. So if you guys are enjoying the video, please, it's a request to subscribe to my channel for more content on AI, DSA, and as well as system design, because I regularly each week provide valuable content on all of this. And please turn on your notifications and please do like the video as well. It actually, just this support helps me create more content. So let's go back to the slide again. Okay, so we are discussing scalability. So it's the system's ability to handle traffic surges. So let's say in during a normal match, it might not be like too many viewers, but during IPL, let's say a crunch match, your food delivery apps actually, you see, it happens during that time. People are watching maybe in a gathering or group, and they order during those matches. Okay, so food delivery apps has to handle lot of traffic, say 10 to 15 times normal traffic in just minutes. So how they do so that's how where scalability comes into picture. So four important aspects are horizontal scaling, adding more servers on demand; load balancing, distributing the requests evenly; caching, because why caching? Because if you are caching the repeated data, then basically you are avoiding hits to your database. And if you avoid hits to your database, your system is not overburdened. So with caching also, we are ensuring scalability. Database sharding, that is also some way we break the data into manageable chunks, and basically we ensure scalability. So horizontal scaling, as I mentioned in the first point, that in adding servers on demand is something of auto scaling. Whenever the threshold is breached, it becomes auto scaled. So good design is equal to scaling without breaking. Systems must grow as fast as demand grows. Okay, so let's move on to the next slide. This is a very fundamental aspect and a very important concept in system design is cost optimization. So basically, what does cost optimization mean? That so whenever you are designing a system, okay, you should ensure that you are not spending on infra that you don't need. You will, if you provision some infra, you will incur cost. But if you don't need it, let's say you need it for a certain purpose or during some IPL matches, for example, the example that I was giving in, then basically you should not over provision, and it should be something like auto scaling. So how does your smart design help in your cost estimate optimization? Caching, avoiding repeated DB queries. So lower compute plus faster response. Right sizing infra, auto scaling instead of over provisioning your servers. Now, next, data compression. The data that you are sending, if you send more data over the network, basically, it should be that you are compressing the data, and then basically, maybe what can be done is that maybe you are storing data in the raw format. If you compressed and stored, you would have incurred less storage. So less storage means that you'd be optimizing your cost. The other thing is serverless or pay per use. Pay only when your functions actually run. And also the fundamental aspect is monitoring your usage. If somewhere you are using a lot of infra, you are over provisioning infra, you must monitor that, hey, I'm not requiring this, they are unused resources. So that's how you do cost optimization. These are the very basic ideas. For example, real world context, companies like Netflix and Uber saves tens of millions annually through caching and infra optimization. Example, one large scale app reduced its infra bill by 40% by introducing a caching layer. Okay, so it's not about only saving money, it's making your scaling sustainable. Okay, so let's recap on what we have learned. Reliability, systems that never fail; availability, always accessible, minimal downtime; scalability, grow as fast as demand; consistency, data stays correct everywhere; and cost efficiency, optimize infra plus usage. Okay, so now I would give you the part one, the five pillars that you have learned, and I would relate it with some everyday analogies. So, reliability is something like a train schedule. Trains may be late, but they always arrive. Systems must always deliver. Availability, you see, if your power somewhere gets cut, then you should have a power backup. So, it keeps the devices running. So, your system should be available during failures as well. Scalability, it's example would be cafeteria queue. When the crowd grows, more counters open. Okay, so systems must be handling growing load seamlessly. Consistency, the same example. Withdraw some amount, it should be shown everywhere. Carpooling, cost efficiency. With carpooling, basically, let's say you are traveling by Uber. So if you do carpooling, basically your cost reduces. So that's analogy to the cost efficiency. Some more examples would be reliability, electricity supply, where you are expected to turn on the every time you flip the switch, systems must deliver without fail. Availability, like a hospital system that must be available 24/7. Scalability, highways during rush hours with more traffic. When traffic grows, basically you have to provision more lanes. It's like provisioning more servers whenever your system demands. Consistency are like digital clocks. Okay. Con- okay. And basically cost efficiency, instead of everyone driving separately, shared buses and trains move people efficiently at much lower cost. Okay. So system design is not only about just theory, it's survival. I hope you liked the video. And in our next video, basically, you would be actually deep diving into the next pillars of system design. There's security, maintainability, performance, and durability. I hope the concepts are clear, and we'll be continuing this further four pillars in our next system design video, which is the episode 2. I hope everyone liked it. So just a plea again, if you enjoyed the video, like the video, and please subscribe to my channel. It helps me support me creating more content, and turn on your notifications. Thanks everyone. Have a good day.